good day to Dr. Zaini. I'm Jevine Lai from Section 7, and today I'll be presenting about my project, which is entitled Power Transmission of a Gear Train System in C Programming Language. My project will be revolving around Chapter 1 of Mechanics of Machine, which is the study of gear systems, mainly on gear train systems. So first of all, let me explain to you what is the concept of a gear train. A gear train consists of three main components, namely driver gear, idler gear, and also driven gear. Driver gear is the first gear which is in contact with the power source, whereas idler gear is the gear which is being moved by a driver gear, and the driven gear will be the gear that transmits the motion or the power towards the mechanism that will be added to the machine. So, in gear train systems, it doesn't matter how many gears we can add in between. For example, it can be odd number and even number. As long as the number of teeth in each gear is known, we can determine the overall torque of this system, which is required to move the overall mechanism. The following are the images of the question which I have chosen to solve using C programming language. It is based on the lecture notes in the course of BDA 20303 Mechanics of Machine by Encik Karanizam Adibon of FKMP Aviation. So here are some set parameters that I have decided where the program written should follow. First of all, the program shall include the input number of teeth in each gear. In the example, there was the use of 4 gears, thus n will be equals to 4. Next, there will be the calculation of gear ratio, as gear ratio calculation is one of the important aspects in calculation of total torque required by a gear train system. Next will be calculation of equivalent moment of inertia, and then the input of the torque, load mass, hoist radius, and also gear acceleration. These four main parameters were given in the question, which user will have to input into the system to calculate out the total torque required by the system. Next will be calculation of torque required in the motor and hoist section. In concept study of gear trains, the calculation of overall torque will be separated into two sections, namely the torque required by the motor section and the torque required by the hoist section. So the program design will first calculate the two different torques, which is torque required in motor section and then the torque required in hoist section. Then we move on to number 6, which is the calculation of overall torque required by the system, which is the addition of the torque required in the motor section and also the torque required by the hoist section. Then another feature that I have added extra into this code is to determine the average load applied to the system and also the average number of teeth in the gear train system. Next is to allow the program to be applicable to solve similar problems. As the example given is very thorough, where a lot of different parameters were used. For example, moment of inertia of gear, moment of inertia of the hoist, and many other different values. This program will be usable to solve similar problems where the values of moment of inertia or the mass or the number of teeth will be different, but may also calculate the overall torque required by the system. Another final requirement that this program shall include is the use of at least 4 loops and also 2 functions, which is one of the main criteria requested for this project. Now I will present the flowchart for the program to solve the gear train system problem. First of all, we will start the program. Next, we will require input of T1, where T1 stands for the number of teeth in gear number 1. And then the system will run a cross-check for T1, whether T1 is more than or less than 0. Because if in any gears where there are no teeth, it shows that calculation of gear ratio, which is done later, cannot be done because there is no ratio of gear teeth, meaning the gear train system is not complete. Next, we require an input of T2, which is number of teeth in gear number 2, and the same process is done to check if T2 is more than or less than 0. And then the input of T3, and also the same cross-checking. okay, which is also being driven here, T4, the number of teeth in gear number 4. Also the same cross check, to check if T4 is smaller than or less than 0. Okay, so this part of the flowchart is the input of all the number of teeth in each gear number 1, gear number 2, gear number 3, and also gear number 4. Next, the calculation moves on to determine the gear ratios, where I have defined in my program as GR8 and GRB. GR8 is the ratio of the number of teeth in gear number 1 over the number of teeth in gear number 2, whereas GRB stands for ratio of number of teeth in gear number 3 and over gear number 4. So this is the calculation for gear ratios. Next, the program will require an input of the equivalent moment of inertia for the motor shaft, the hoist shaft, and also the middle shaft, and also the efficiency of the system. So there will be an input section for moment of inertia of motor, moment of inertia of hoist, which is the moment of inertia of the middle shaft, moment of inertia, and also the efficiency of the motor, which I have defined as these few parameters in my program. Next, the calculation of the equivalent moment of inertia for the whole system will be conducted, whereas I equivalent is equals to moment of inertia plus IT to the gear ratio A power of 2 divided by efficiency plus IG times gear ratio A also to the power of 2 multiplied by GRB, gear ratio B, to the power of 2 divided by the efficiency to the power of 2. So this will be the calculation for the equivalent moment of inertia for the whole system. Next, the program flows to the input of the gear acceleration, which is denoted as GST, and also hoist radius, which is denoted as RD, H in the program. This is the input for gear acceleration and the hoist radius of the gear system, gear train. This is the input of the gear acceleration and hoist radius of the gear train system. Then, the system will calculate for certain parameters in the midst of calculation for overall torque, where is the calculation of ratio here, is the multiplication of gear ratio A and gear ratio B. Alpha G is the angle in between the gear ratios, alpha M, and also Tm1, which is the torque required by the motor section. Next, the program will require the input of load 1 and load 2, which are the masses subjected to the hoist, where the hoist is supposed to carry these two loads in the gear train system. After obtaining the load, the input load, there will be calculation of F1 and F2. The torque required by gear, which is denoted as PG, and also the torque required at the hoist section, which is denoted as PM2, and also the overall torque required by the system, which is the main purpose of this program. So after calculating these few parameters, F1 and F2 based on the mass, TG is the torque of the gear, and also TM2, the overall torque required by the hoist section. There will be calculation of T total, where T total stands for the overall torque required by the system, which is the addition of TM1, which has been calculated here, and also TM2. So TM1 plus TM2 to be the total torque required by the system. Then the system will display total torque. In our case, T total was 1006.32, which is the same displayed in the system and also the example which is used for this project. Next, there will be another section where the program calculates the average number of teeth in the system and also the average load applied to the system. So I will end this here at D. Then, and that will be all for the program written for this project. Python has managed to fulfill all the requirements that I've set earlier on from this presentation. And I've also managed to solve the program code with the use of more than 4 loops, and also 2 functions in extra rather than in main function, which was the efficiency function and also the gravity function. So based on that 2 functions and also the program code of over 150 lines I have written, I was managed to solve the total torque required by the system, which is exactly the same as the example I've used for this project. So that is all from me for this presentation. Thank you very much.